Hello and welcome to today's smart class. We have a nice exponential challenge here. The question is x to the power of x equal to 4 to the power of x plus 4. What then is the value of x that will satisfy this challenge here? Now, if you look at this, it appears easy, but how do we solve this algebraically? If you are not too conversant with the laws of indices and some manipulations of exponents, then you would be able to solve this. So let's see how we solve this algebraically. So we're taking our solution first. So we have our solution. All right. So we just have to rewrite this side of the equation, which is the right-hand side of the equation, applying the law of indices. So the first law we're going to apply says that when you have your a to the power of your m plus n, this is equal to your a to the power of your m times your a to the power of your n. Okay, so we are having the bases to be the same, and so we have a multiplication there. We add the powers. So we rewrite this. This is going to give us x to the power of x equal to our 4 to the power of x times our 4 to the power of 4. Okay, so let's carry the terms that have x to the left-hand side of the equation. And how do we do that? We divide by 4 to the power of x. So if we divide this by 4 to the power of x, we equally divide this by 4 to the power of x. So this will live with this. We are now having another law playing out again. But let's write this expression out. We're having x to the power of x all over 4 to the power of x is equal to, here we are now having 4 to the power of 4. Okay, now see what we now have here now. We are having x to the power of x and 4 to the power of x at the bottom. So we succumb to a law which says that when you have your a to the power of your m all over b to the power of your m, this is same thing as a all over b all raised to the power of m. And so we can rewrite this side to give us here our x to the power, x all over 4 all raised to our x here equal to, we are having 4 to the power of 4. Okay, so the next thing we're going to do here is this. Let's try to eliminate this x as the exponent. And what we do here, we're going to multiply or raise both sides of this equation to 1 all over x. And so we're going to write this. This is going to give us our x all over 4 all raised to the power of x. Then in brackets, raised to the power of 1 all over x. Then we do same thing here. Our 4 to the power of 4 all raised to 1 all over x. Now look at this expression here. We apply the third law of indices here. The law which says that when you have your a to the power of m times n, this is same thing as a to the power of m, or in bracket raised to n, which is also a to the power of n, or in bracket raised to m. So we can use this to open this because this is power, this is power. So if we multiply out, this and this will leave. So with that, we're going to have a very nice expression from this. How? And so this is going to give us x all over 4 only equal to, we also use this to multiply this, and this is going to give us our 4 to the power of 4 all over our x. Easy. Wow. So with what we have here now, we're going to do a simple substitution here. So how? Here, let's take a substitution. Let's say let's take t, okay? Let's our x all over 4 be equal to t. Look at the relationship between this and this power here. The x here is at the numerator and 4 is at the denominator. But here we are having 4 at the numerator and x at the denominator. And so this is more or less a reciprocal of this. So if we are saying let x all over 4 be equal to t, if we decide to find the reciprocal of this expression, we're going to come up with 4 all over our x will now be equal to 1 all over t. Easy. Good. So with this we have in here now, let's substitute these two quantities in our equation here. So this equation will now become our t will be equal to our 4 remains here, 4 all raised to the power of 1 all over t. Are we learning something here? Good. So with what we have here, we want to eliminate this power again. So how do we eliminate this? We're going to raise the powers here to t. Raise this one to t. And so this is going to give us our t to the power of t. This is equal to 4 to the power of 1 all over t, all raised to the power of t. Now we come to this law again. So if we apply the law to this other side, what happened? Then this, we live with this. Okay, so when we have this out, there we're going to have our t to the power of t equal to 4. Good. Now look at 4. 4 is a perfect square. So we can write 4 as 2 to the power of 2. So rewriting this is going to give us our t to the power of t is equal to 2 to the power of 2. Look at the left-hand side of the equation, t to the power of t. Okay, so this variable to is raised to its own self, then this constant raised to its own self. So we can equate the exponent or the base. And so it all means that our t is equal to 2. Now let's keep this value here. We do not have t in the initial equation, so we go to where we say let our x all over 4 be equal to t, so that we can get the actual value of t. So from here we can now say recall that our x all over 4 is equal to t. So what is our t? Our t is 2. So we put 2 in place of t. So this is going to give us our x all over 4 is equal to 2. When you cross multiply, this is going to give us x is equal to our 4 times our 2. So we have, therefore, x is equal to 8. So 8 is the answer to this wonderful exponential equation. But let's see if this actually satisfies this equation, or if the solution is an extraneous one. So take our check. So we have our x to the power of x is equal to our 4 to the power of x plus 4. So let's go ahead and put our 8 in place of x here. So this is going to give us our 8 to the power of 8 is equal to our 4 to the power of 8 plus 4. So we now have 8 to the power of 8 is equal to our 4 to the power of 8 plus 4 will give us 12. So we have here 12. If you compute 8 to the power of 8, what will that give you? This is going to give you 16, 7, 7, 7, 2, 1, 6 equal to, and again, if you compute this will also give you 16, 7, 7, 7, 2, 1, 6. It's a large figure. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So this gives us 16,777,216. Okay, and so this shows that the answer we solve for, which is x equal to 8, actually satisfies the original equation. So give the video a thumbs up if you find this video facilitating, and you have any question with regards to the steps I apply here, then drop it in the comment section. Again, if you have a better way of solving this, an alternative way of solving this challenge, drop it in the comment section so that we can equally learn from you. Thank you for being there. See you in our next class, but till then, keep winning. Bye for now.